All right, so once you're signed in, guys, okay, what you're looking for is both in the stream where it says I posted a new assignment, Properties of Compounds Lab. It's also in the class work tab, Properties of Compounds Lab. Okay, if you go in there right now, there are 3 things in there. There's a PDF document, that's the lab sheet. You don't need to do anything with that except read it. That's okay, where the instructions and stuff are. There's a video here. You're not going to need that video until after tomorrow, or if you're not here tomorrow, that's the observations. That's me performing the lab. Okay, so if after tomorrow's lab maybe you don't finish, which shouldn't happen, or if you're absent, okay, this is how you get the data you need to do the lab. Okay, if after tomorrow you're not confident in your data, it's not a very long, well, it's 25 minutes, but I mean, you watch it and you can confirm whether your data is correct or not. Not maybe worth the time. Okay, and then there's a Google Doc. That's the thing you need to have open right now. Okay, so if you can open up, it won't say student code error, it'll say your name. Okay, U1 Properties of Compounds Lab. That's the file you need to have open because that's your lab report. That's what you're going to hand in to me. Okay, this file and only this file will be accepted when you turn it in. Okay, don't hand me in something else. Okay, I don't want something that you made on your Mac. I don't want a PDF from somewhere else. I want this Google Doc. This is where you do all your work. Okay, because I'm trying to save you time. As you can see, it's already pre-built. Okay, basically it's just a template. You have to fill it in. Okay, so this is the skeleton. You're going to put the muscles and flesh on it, okay, and make it better. All right. So you're going to be working in this document, okay? Today we're going to work on the problem, the design, the hypothesis, and writing out the procedure. Tomorrow, you're going to need this chart for the lab, okay? So that you know where you can put in all of your observations. And of course, you're going to need your procedure to follow tomorrow. Okay, questions so far? All right, so you guys are going to be working in this. I'm going to have a different screen up here that I'll be working from, okay? And then as I go along, you're going to want to type furiously, okay, as we go. Because I'm going to give you some pretty big, juicy hints about what you should put in each section. Because on this lab report, as I said yesterday, I'm really going to be holding your hand because it's your first high school lab report. Okay, it'll give you an idea of what I expect in terms of detail for each section. Okay, so for the problem, okay, the problem we're investigating is how can substances be identified from their physical properties? Okay, remember yesterday when we went through lab report format, your problem needs to be stated in the form of a question in your own words. So what's written here, and by the way, this is the PDF document that's in with the assignment, so you actually have a copy of this as well. Okay, the problem here says, given several unknown samples, how can we classify them as ionic, molecular, acids, or bases in order to find their identity? So if we're breaking that down, simplifying it, writing it in our own words, okay, basically we're trying to identify unknowns from their physical properties. Put that in your own words in the form of a question. Okay, what we're trying to do is we're trying to identify unknowns of just their physical properties. Okay, now something else that often comes up when we're doing lab reports. Your lab report needs to be an independent creation. Okay, every person is handing in their own unique lab report. Is it okay if you work with other people? Yes, absolutely. There's nothing I can do to stop you from doing that, and I encourage you to do that. That's fine. What I don't want is 4 identical lab reports with different names coming in, okay? Because then I look at that and go, okay, who did all the work? Okay, because that's inevitably, what happens when I get 4 identical lab reports is one person did all the work and 3 people freeloaded and didn't learn anything. Okay, so each person hands in their own lab report. Now, are there going to be similarities between everybody's lab reports? For sure there are, okay? And things might sound a lot alike, but it needs to be just that little bit different for each person so that I know that you did your lab report. So if you're sitting down, working with a friend, and you're coming up with your procedure, okay, yeah, your procedures are probably going to be pretty much the same. That's fine. I expect that, okay? But what I don't want to see is 4 hypotheses that are exactly the same word, okay? Find a way to make it yours. Right? Everybody kind of follow there? All right, so the next part that we have to go over is the design. So that's our manipulated, responding, and controlled variables. So again, review from yesterday. The expectation here is that you identify your manipulated variable and you explain how it's being manipulated and why it's being manipulated. For your responding variable, you identify what variable is responding, how it's responding, okay, what that's going to mean. And then you need 3 controlled variables. Those are the variables that have to stay the same, okay, throughout the experiment so that they don't interfere with your results. Identify, explain how they're being controlled, and why they're being controlled. Okay, so this is a big section of the lab report, and it's worth 5 marks out of 35. Okay? All right, so in this lab, we're going to be running the tests we talked about yesterday. Okay, the Observable Properties test, the Solubility test, the Conductivity test, okay, the pH test, and yeah, that's it, those 4 tests, okay? So we're going to be running those tests. We're going to run those tests on every single unknown compound, okay? So the tests are staying the same. But each time I run the test, I'm running it on something different. Okay? So in other words, I'm performing this lab almost 12 times, okay? Because there's how many unknowns?
Each different, there's 12 different unknowns.
12 different unknowns, right? Okay, so what's being manipulated? Each time I run the tests, I'm manipulating what I run the tests on. So, guys, I just gave you the answer, okay? I just told you the manipulated variable is the different unknown substances. Okay, so now what you have to do with that, I've given you the identity. Now you have to explain to me how is that being manipulated, which I kind of already said a few minutes ago, okay? And why is it being manipulated? Okay, for the why part, think about this. Everything is supposed to have its own unique physical properties that could identify. Okay. Now, I'm probably not going to give you enough time to get this all typed, so maybe like type a few jot notes and you can come back to it. Here's the other thing you can do. What am I doing right now? I'm recording everything I say. Can you go back and listen to this again? You'd be crazy not to. Okay? I'm going to be perfectly honest with you. If you talk to anyone who's taken my class before, if you want to do good on labs and assignments, you go back and listen to Coderre's instructions a second time and make sure you did everything right and got all the giant hints he drops, okay, in class. All right? Because when I read through somebody's lab report, if it sounds like I said it, I like it. And that's not like an ego thing, it's just that you're going to get it right. Okay? If somebody writes exactly what I said not to write, well, that'll agitate me. And you don't want me agitated when I'm marking your lab. Okay? Okay, our responding variable. The responding variable is the thing that's going to change as a result of our manipulated variable. So I test substance A, okay, and then I test substance B. What's going to be different? The test results, yeah. Okay? I should get different physical properties for each unknown material. So there you go, I just gave you the answer. Okay? The responding variable are the physical properties / test results for each unknown. Your job, explain how and why. That's the responding variable. All right, the next thing, we need 3 controlled variables. That is 3 things that are either kept the same or that we do the same each time we run our lab. Okay, now I already kind of gave one away. Okay, each time I test a new substance, do I test it the same way?
Or yes, you do.
I do. I run the same tests, right? So the same tests is one of the controlled variables. Every substance is going to be tested in exactly the same way. That's important. Okay? It would hardly be fair if I tested one substance, just 2 of the tests, and another substance, all 4 of them. So your job, explain how it's being manipulated and why. Okay, in other words, the why part is, why does that need to stay the same? Okay, how are you keeping it the same is easy. I'm just gonna do it the same every time. Don't use I, but like, it'll be performed the same way each time. Why? You tell me why. Why do I need to do it the same each time? Okay, so that first controlled variables come in 2 types, procedural and environmental. Okay, so that first one is a procedural controlled variable. It's how I'm doing something the same. Okay, environmental controlled variables are things that are kept the same because they could affect my results. Okay, so I'm testing things like solubility, state of matter, pH, stuff like that. What's something that's going to stay the same in the lab that could affect those? Temperature, absolutely. Okay, temperature affects solubility. Temperature affects the state of matter, right? If I raise the temperature just enough, some of those things might change from solid to liquid, okay, or liquid to gas. So yeah, certainly it's important. I might have just given you quite a bit of that one actually. Okay, I think all you need to have in there is the how you're controlling it. It's that little thing on the wall there above the light switches. Thermostat. So don't touch the thermostat in the lab, during the lab. Okay, I've given you 2 controlled variables, one procedural, one environmental. You come up with a 3rd, okay? You don't have to come up with it right now, okay? After we talk about the procedure, you might think of a 3rd one and you can go back and put it in, okay? But I'm gonna make you come up with the 3rd one. So identify, explain how it's controlled and why it's controlled. How is basically exactly that. What are you doing to make sure it stays the same? The why, what effect will it have on the experiment if you don't keep it the same? That's the why. Okay, so you gotta come up with the 3rd one. All right. The next thing, for 5 marks, is our hypothesis. Okay, what are the 3 words that have to go in a hypothesis? If and then. Those words have to go in a hypothesis. Okay? The if part talks about the premise that we're working on. It often relates or talks about the problem. Okay? So remember, our problem is, how can the physical properties of a substance help me to identify it? Okay? So that would imply then that all substances have at least a unique set of physical properties. Would that be fair to assume? I mean, if that's not true, are we going to be able to identify all of these? Because if it's not true, what it's gonna mean is I'm gonna test a whole bunch of different substances and they're all gonna give me exactly the same results. Okay, that's not true. Okay, we know matter doesn't behave that way. We know that all matter has unique physical properties. That's the premise. Okay, so the if part of your hypothesis needs to talk about unique nature of physical properties. Okay? Okay. If each substance has unique physical properties, and elaborate. Okay. The and part of a hypothesis briefly describes the experiment. Okay? This experiment, basic or simple tests are being run to determine the physical properties of the materials, like color, solubility, pH. You could even mention a few of them. Okay? So the and part is just a brief description of the experiment. So, and basic tests are run to determine physical properties like this. Okay, all you have to do is it's just a brief description. Your procedure is the detailed description. Okay, you just need a brief description. The then part predicts our findings, okay, essentially. So follow me through this. The premise we're working on is that all substances have unique physical properties. And tests are being run to determine those physical properties. Then the results will be that each substance will have a different set of, well, let's try not to use physical properties again because we've used it like 4 times now in the same sentence, okay? But let's say like observations, results, or something like that, right? Okay, there's gonna be, and that will allow us to identify, okay? So there has to be that, this is what will happen, and this is what it'll let me do, okay? That's what goes in the then part. So then predict results, okay? And what they'll let you do. Okay, and what we're looking to do here is identify all of our substances. Okay, so this is a pretty long sentence. Probably an English teacher would say it's a run-on sentence. That's their problem. I'm going to file that under their problem, not mine. Okay. Now we're going to look at the procedure. Okay. We know there are 4 tests that we need to run, so we need to describe those 4 tests in our procedure. But even before that, okay, we have to establish some safety stuff. Okay, what's the first thing a person should do upon entering the lab? Yeah, put on lab coat, safety goggles, okay? I mean, you can be a bit more general and say acquire safety equipment, i.e. goggles, Okay, like yes, certainly that's important. For me at least, it's definitely the eye protection. Okay, if your clothes get ruined, you'll live. Okay, if you're blinded, you'll live, but you'll be blinded, and I can't live with that. So, okay, you got to have the safety goggles on at the barest minimum. Okay. What should I do next? Now I've got my goggles on, I'm sitting at my lab station. Can I do anything yet? What don't I have? I don't have the materials yet. They're still at the front. Okay, so what do I need to do as my second step? Acquire the materials. Okay, so you can talk about what materials need to be done. Once you've got the materials, then you can start describing the 4 tests. Okay, and this is the part you're going to work on through the bulk of class with your group. Okay, so the 4 tests, observable properties. Okay, I'll put them back up here on the board so that you'll have them there. Then you and your group can decide how you want to word it. Okay, but the observable properties test is the one where we look at like color, state, crystal shape, all that kind of stuff. After the observable properties test, then we do the solubility test, which includes adding water, taking the temperature while the dissolving or not dissolving is going on. Okay, we're recording whether it's dissolving and whether the temperature is changing or not. Okay, then we're going to do the conductivity test, where we take the conductivity apparatus and we put it in the solution, okay, and we test the conductivity. And I'm going to bring those things over here in a few minutes just so you can see what they all look like. And then we're going to perform the pH test, which just is the pH paper in the solution, check it with the side of the pH container. Okay, so I'll show you all that stuff here in a few minutes. The big things for the procedure, it can't just be perform pH test. Okay, it's got to be perform pH test by, and then explain how they do it. And explain or identify what observations need to be made and how. Remember, this is an explicit step-by-step set of instructions. It's a numerical list. Okay, this step requires you to do this and this and record this and this. Okay, it's got to be really detailed. That's why you're getting the rest of class to work on it today. All right, that's like another half an hour. Okay, shouldn't take you too long. Now, do I need to write that set of steps out 12 times for each substance? Please don't. Okay, it's a lot of scrolling for me. Okay, when I'm marking it. So all you need to do is identify the steps, and then when it's all done at the end, okay, your second to last step will be repeat steps like 3 through 7 or 3 through 8, whatever it is, okay, for each unknown, and then people will know to just kind of go back and forth. What's your last step? What do you do at the end of the lab? Clean up, yeah, okay? Now, don't just write step 8, clean up, okay? Clean up is specific, right? What should you do with all of the containers and apparatuses that you use?
Clean them or wipe them, clean them out.
Yeah, like wash them off in the sink, okay? Dry them off, bring them back to the front, okay? Put your safety glasses away, okay? Wipe down your station, right? All that kind of stuff, okay? That's all also included in a procedure, okay? All right, what I'm gonna give you now is about 3-4 minutes while I go get the materials to show you what they look like, okay? Is to figure out your groups. Groups of, let's say, 5, okay? If we got a couple of groups that are smaller than that, fine, but let's not go bigger than 5 because that's getting a bit crazy around the lab stations, okay? Please make sure to include everybody, okay? If there's someone who's new or whatever, please make sure that everyone is included, okay, in a group. If at the end, if I have to, I'll put people in groups, that's fine, okay? But I'll for now let you guys choose your groups. Just make sure everybody gets included, okay? All right, I will be right back with the materials to show you what they look like. All right, so in this list of materials here, okay, are also the identities of your unknown compounds. Okay, so one of your unknowns is ammonium nitrate. Okay, one of them is copper 2 sulfate. One of them is ethanol, that's alcohol. One of them is paraffin, Okay, paraffin is candle wax. It's the stuff candles are made out of. Okay, sodium chloride is one of them. Sodium hydroxide is one of them. Hydrogen chloride is one of them. Okay, sucrose, sugar. Okay, water, cobalt 2 chloride, and nickel 2 chloride. Okay, are your unknowns. Okay, now when you're doing the analysis, which is obviously not today, okay, what you want to do is kind of look at those things and think, all right, what might the properties of this thing be? So, an easy one. Copper 2 sulfate. What kind of compound is it? Okay, it's ionic. All ionic compounds do what that molecular compounds do not? Conduct electricity when in solution. So right away I know that that material should pass the conductivity test. Okay, it should have a high number during the conductivity test. Because it's got copper in it, it should also have a blue solution. Should be blue in color. Okay, is this helping me out? Okay, is it a strong acid or a strong base, or is it somewhere near neutral? Okay, quick review from the other day. Strong bases have hydroxide OH ions, and strong acids have hydrogen acting as the metal. Does copper 2 sulfate have either one of those? Then it's not going to be a very strong acid or a very strong base. It might be slightly acidic or slightly basic, like 6 or 5, okay, or maybe 8 or 9, but it's not going to be 13 and it's not going to be 1. Okay, it's definitely not going to be extreme in either case. So that's what I got to do. I've got to look when I'm doing my analysis, what are the properties of this? Then I look at my observations and go, okay, substance B has those properties. So substance B is copper 2 sulfate. Spoiler alert, it's not, but okay, just so you know. Right, that's how we would do it. Does that sort of make sense? Okay. So when you're making your procedure, okay, these are the materials that you're going to have, all right? So this thing here, okay, is called a depression plate, okay, because it has depressions in it, not because it's set, okay? All right, so it's got these depressions in it, okay? When I'm saying like acquire the materials, should I say how much? Like, is that important?
Yes.
Yeah, because if I don't, someone's going to fill this thing all the way to the top with the unknown material. Then how are they going to perform any other tests? They can't add water to it, it'll spill. Incidentally, don't contaminate your other solutions. You can only test 6 at a time, obviously, and there are 12. Okay, so you can only test 6 at a time. I would say the ideal amount of each unknown is enough to cover the bottom. Okay, so if you have enough there, so the amount that I've got in that depression plate right now is enough. Okay, it covers the bottom of the depression. Okay, that'll be ample. All right, when I'm doing my observable properties test, okay, this is what I do. All right, it's a white crystalline solid. The crystals are very small and cubical. Okay. It has no discernible odor. Okay. It's obviously solid at room temperature. Okay. Beyond that, I can't observe much more. Okay. For observable properties, it's a white crystalline solid, and that's about it. Okay, with no discernible odor. All right, what should I do next? France, what should I do next?
Solubility.
I should do a solubility test. Okay, so to do your solubility test, you're going to take a wash bottle. Each station will have one of these. They contain distilled water. Okay, how much should I add? Well, I'd say fill it till it's like 2/3 to 3/4 full. Okay, that should be ample to get it to dissolve. But what do I need to be doing while this is happening, while I'm adding water?
Temperature?
Yeah, I got to use my thermometer. You probably call it a thermometer, but it's the same thing. Okay, so I'm gonna have a thermometer. What's the little plastic thing for? What's happening to the thermometer right now because I'm holding it? It's getting hotter. That'll happen even if I just had 2 fingers on it. This keeps your fingers off the glass. Okay, so your body heat doesn't interfere with the readings. Not all the thermometers have one of those. Okay, if it does, use it. If it doesn't, hold it by the top as best you can. Okay, now I want to put that thermometer in first and then add the water. How do I stir? I do stir. Do I stir with this? This is not a stirring rod. This is a stirring rod. Just a little glass rod. If you stir with this, you break the thermometer. Those are expensive. Glass rods, not expensive. Okay, so this is a 2-person job. Okay, I'm gonna have one person holding the thermometer, okay, another person adding water and stirring while the water is being added. Okay, and I'm gonna be observing any temperature changes while that occurs. All right, so as we said, I'm gonna add water until it's about 3/4 full, and I'm gonna watch the temperature. Okay, I think I'm getting close to 2/3/3/4 full. All right, am I realistically gonna get all of this stuff to dissolve in that much water? Even if it's really soluble? Probably not, okay? But what do I need to watch for? What are some signs that I might want to put in my procedure that indicate something is soluble? Temperature change could be one. In fact, this is dropping. Okay, it's down now. It went from 23, it's already down to 16, and it's still dropping. Okay? Incidentally, your ammonium chloride there, sorry, ammonium nitrate, sorry, will do the same thing. So that might help you when you're doing your analysis. Ammonium nitrate during the solubility test is going to get colder. If you've ever used one of those commercial cold packs where you pop the little water bladder and then it gets cold, that's what's in there. Okay, so this is still getting colder, okay, it's down to about 15 now, okay, and I can see that the crystals are shrinking. There's less of them, okay? But I'm probably not going to get it all to dissolve, and that's fine, okay? But it's definitely fairly soluble. I bet if I kept stirring, I'd get most of it. It's almost all gone, okay? So that's what I'm doing, okay? You can see there's a lot less white stuff in there now than there was to start. All right? Everybody okay with that? Okay, so that's your solubility test. What should I do with the thermometer and the stirring rod?
Clean them.
Yep, rinse them with the wash bottle. Okay, just take it over the sink, spray it, okay, with the wash bottle. All right, next test. Conductivity tester, okay? These ones are fancy because they actually indicate whether the battery is dead or not. Okay, so when I press the button on the side here, the little red on light comes on, okay? Now, when I put this in there, it's reading 8. Is that pretty conductive? Is this ionic or molecular? It's ionic. All right, well, I just learned something. Okay, highly soluble, conductivity of 8. Whatever's in here is ionic. Okay? All right, what do I do with this? With distilled water. Okay, last test. So, each group will have a little tube of Hydrion paper. Okay, you can see on here there's a color scale, okay, that goes with the pH scale. Inside are little orange strips. Okay, one orange strip should be able to do 2 unknowns. Okay, so just rip them in half. All right, so I just take the strip, I place it in the solution, I take it out. It really didn't do much. I'd say that could be, it's probably a 6. Yeah, I'd say that's 6. It's definitely not 7. 7's a little greener. That's a 6. What do I do with this? Throw it away. Yeah. Okay, just chuck it. All right, can you guys put those into words for your steps? Okay. Did that take very long? I did all the tests and it took me Well, I mean, I stopped and explained whenever, but it shouldn't take too long for you to get the tests done. All right, you got the rest of the class to work on the procedure. You may. Okay, you can get back together with your groups, guys, and talk about it if you want, okay?